Hello, welcome to vsdevelopers.io. Today, we will be looking into macros and inline functions. Historically, from C language, we have been using macros, that is hash defined statements, which are performed by preprocessor much before the compilation begins. In order to continue the advantages of macros, the C++ has continued to enhance them and introduced inline functions. Now, how the inline functions are better than hash defined statements? What are the drawbacks of macros? And what inline functions enhance and enable us to use the object orientation, especially encapsulation, by utilizing and leveraging the advantages of hash defined macros. Let us dive in. We know functions and how they get called, and there is a cost associated with it, right? So when you have a function, right, called say fun, and it has a definition, be it a member function or be it a regular function outside of the class, and then from elsewhere you call this main, let's say from main you call this function. Now, when the control flow, when it comes to this one, so what it has to do, it has to create a stack frame and then store its address in the main stack frame. So if you have another stack frame which belongs to main, and then a new stack frame will be created as soon as the fun gets called. So when it gets called, the control jumps here, and when this is over, it has to come back to execute the statements below the fun call. So therefore the address is also stored where it has to come back. And now, so when you call, the stack frame gets created and all the local members are generated here. The memory for them is created here and stored here. And after the successful execution of this fun, you will go back to main and execute the remaining statements. This is a regular function call, how the calling happens and the called function gets executed. What is in it? It is a straightforward, simple activity that we have been understanding. Now, there is a cost associated with it. Do you agree? So, the creation of a stack frame and jumping back from the stack frame, creating memory for it. So, there is a cost associated with it. Therefore, you would look for a function that is very cost effective. So, what if I have a function, at least it looks like a function, but there is no the stack creation, calling and returning from the function? Well, so that is called inline function. So all the cost that is associated with creating a stack frame is not there, and then jumping into the definition is not there. Wherein when you call a function which is inline, let us call it ifun inline function, what happens is its definition will be replaced here itself. You're getting it? This is the key point. In a regular function, as soon as a function gets called, you will have all these set of activities to be done. Now, if it is an inline function, the definition of this ifun will be replaced here itself. Wherever you have called the ifun, all the definition statements will be replaced here as individual statements. And guess, when will this happen? Will it happen as part of compilation or will it happen as part of linking? You know, with a regular function call, there is an activity called linking. So every function call should be found during the linking process. Here with inline functions, the new concept that comes before compilation itself, that is called pre-processing stage. So in all the stages of your source code to execution, pre-processing is the first stage. Then comes compilation, then comes linking, and then your runtime execution. So among these four stages, the very first step is pre-processing. You will take the advantage of this pre-processing to speed up your application runtime. Well, let us understand this with an example of code and in comparison with C macros. The C macros, C style macros can still be used in C++. So now what is the difference between the macros and inline functions? Let me introduce a keyword in order to improve the performance of your application. C++ comes up with a new keyword in order to improve the performance of your inline functions. Yes, the keyword is inline, as the name suggests. So it is inline is the new keyword that is introduced in C++. So this keyword is not present in C. It's only introduced to leverage the functionality of C macro style definitions and yet overcome the pitfalls that are present in C macro definitions. Now, how do you typically define a macro? So you have a keyword in macro definition called define. Right? So these are the new keywords that you are getting introduced to now. So you would typically write hash define, which is similar to your hash include. So this tells that this happens before compilation. So this should be found before compilation. So this will be checked against before the stage of compilation itself. So I wanted to define, say, pi value. So the pi, I say, and define it to 3.414. Well, so this is a macro. What does it mean? Now you have say main method, and inside this main method you are doing some calculation. Well, so I would say int result is equal to, I want to multiply 3 times of pi, and that's all. Now during execution, what happens? So this value gets replaced with 3.414 at the time of compilation itself. So when this pre-processed, this your source file, let's say your source.c is pre-processed first and then sent to compilation. So by the time from preprocessor it goes to compiler, the code looks like int r is equal to 3 multiplied by 3.414. So this is how it works. Now what you're doing, instead if you want to define a function for pi value, which is like a get function, right? So the get function involves in all the overhead activities that we have discussed. Now, so this hash define is this way you define, and inline, how do you go about inline? Is this also followed by, prefixed with a hash symbol or the pound symbol? No, it looks like a regular function. Why it has to be a regular function, right? So hash define, the one that you see here, is usually declared top of the source file, either header file or source file. Well, now what is the scope of it? You tell me, what is the scope of this hash define macro? The hash define macro pi is accessed across your file. If it is in header file, whoever includes the header file can access this pi. I can't bind a scope to it. So therefore, there is a tendency to use incorrectly. A programmer who is working remote might think this is some other value and can use it. I can't restrict this program to be used only by a set of classes or only one class. That's where the inline functions bring the encapsulation capability, the mutability into, it is they bring it to your object orientation. So they give you the advantage of high performance, and at the same time they include as part of your object orientation. Therefore you should use inline functions as against macros. Let us look at this program to understand how macros work. Now as you have seen, the keyword is hash define that we have used here, right? So the first macro, what does it say? So it says wherever you call the fun of x, it should add 1 to it and replace, right? So for example, let me look at here the line number 10. So in line number 10 we are calling fun of 1. So what is it supposed to return? It is supposed to return 1 plus 1 2. Why? So at the pre-processing stage the fun of 1 will become, right, so it will be replaced with x plus 1, and the x value sent is 1. So at compilation, this statement gets translated into x plus 1, and during runtime it will become 1 plus 1, which is supposed to print 2. So this is a first example. Now you take an example of hash defined floor x comma b. You're passing two values here, x comma b, and then what are you doing here? You're comparing if x is greater than or equals to b. If x is greater than or equals to b, then you are printing 0, else 1. So let's take an example here. So floor, right? You are calling the floor macro, and then you what are you doing? B, and this is a bitwise AND. So you are doing bitwise AND operation with 0x 0f. Now, so what is the value of B, right? You have declared it here as 1. Now your 1, and you do bitwise AND operation with 0x 0f, right? So 0x 0f, and then your second value, that is b, you are sending 0x 07. Now what is supposed to do? So you are supposed to first perform this bitwise AND operation and check if the bitwise AND operation resultant is greater than 0x 07. If yes, print 0. If not, print 1. So in this case, right, it is b is 1, which is your 0x0000 and 0001. And you do bitwise AND with 0x0f, which is 0x000, and it is f, which is 15, right? So you write 0, okay. Okay, I have some writing issue here. Let's see. So this will be AND operation, so it will be 1, right? So 1 1, and it gets translated, I mean it gets converted into 0, 1 and 0, because it's AND operation. So it will be 1. So when it is 1, 1 is greater than 7, 0x07? No, it is not. So it is supposed to say, it is supposed to print 0. So that's how. So here the replacement happens, right? So b and 0x0f. Will this all be passed here, or the AND operation is done first and passed there? So as it is a pre-processing activity, what happens is this b and 0x0f is as is replaced with x. So your x comma b, so x value is b and 0x0f is greater than or equals to your b value, which is 0x07. So during runtime, this AND operation happens. It's not at the beginning, right? So then the result should be 0. Well, so that is about your second example. And third example here is your band function. So you're passing x parameter, and then if x is greater than 5 and x is greater than less than 10, then you print x, else 0. Well, what happens? So here is the problematic situations with macros we should be careful about. So these are all demonstrate the same. The first and second are fixed in the latest compilers. Otherwise, the compiler wouldn't throw any error, but the result will be unambiguous. That is, result will be ambiguous. You wouldn't be able to predict why such value is coming. But the latest compilers like C++11 and above have solved that issue. They first throw you the compilation error itself. So in these two cases, you will be all good. So you will not be thrown any error. There will be warnings though. We will look into them. So here, what are you doing? The third example, you have initialized I is equal to 4, and you want to run I for until it is less than 11 and plus plus. Well, so a is, what is a value? A is equal to I, so which is supposed to be 4. So it's supposed to print 4 first. And then what are you doing here? You are using a hash defined macro here, band plus plus a. But since it is a macro, first it wouldn't be pre-incremented. First the band plus plus a is replaced. What is band plus plus a? Wherever you find x, you simply say plus plus a greater than 5. Then and plus plus a less than 10. You see, so you are incrementing this value twice, which is not your intention while you're coding. Then you are printing the value of a. So you will see how things go terribly wrong, which is very difficult to debug and identify. Well, so therefore you must be extremely careful when you are performing any arithmetic operations or bitwise operations with a macros, hash defined macros. So this problem will not be present when you are using inline functions. Is it so? Right, because inline functions also do the same thing, they replace the statements. So whatever you see here is still applicable to your inline functions, but there is a catch, right? So instead of you defining it this way, you use the inline keyword and define it as a program, as a member function, right? So compilers have become intelligent now. If that inline program is not optimized to be inline program, then the compiler automatically ignores the inline keyword. This is an interview question. This is a very powerful interview point. Is inline function is going to is going to be executed at pre-processing time all the time? Can you guarantee it? No. The compilers, preprocessors have become intelligent. If it is cost effective than a function, only then they use the inline keyword and they replace it at the pre-processing stage. If it is not cost effective to a function, then they are treated as a regular function. You have an example with inline keyword. Well, so what is happening here? Now you have declared a set function, set method as inline. And now whenever you call a dot set of 100, so before its compilation stage, it would be replaced as I is equals to 100. How simple is it? So now all the overhead of function calling and stack creation, destruction and returning is eliminated. So therefore you will find improved performance with inline functions. And whereas a.read is a regular function. Well, so it simply returns, it has the overhead and it returns 100. So this program prints 100 as an output. So this is a simple demonstration of how do we use inline keyword. Now all the constructors by default are inline. Remember that that's an interview question. You might get it in written tests or you may be asked in verbal interviews as well. So all the constructors are inline by default. During the performance cost evaluation, if it is not cost optimized, then it would turn out to be a regular function. All right, so this is a demonstration of your inline functions. Here is the summary of what we have discussed. Macros and inline functions help us to improve the performance of the application. And with caveats though, you should carefully be thoughtful about what functionality are you going to keep under macros or inline functions. Either macros or inline functions are very difficult to debug sometimes. That is when they are used in ambiguous statements, ambiguous arithmetic expressions. You will get an output that is difficult to interpret. Therefore, they should carefully be chosen. Now let us see the differences that we have observed using code examples. As defined macros are global to the scope. They can be used by any method, any class. Inline functions are encapsulated into a particular class. Hash defined macros are accessible to everybody. Inline functions are made accessible to only the class members. Constructors and destructors are by default taken as inline functions. It is not applicable to macros. Both of them help improve the performance of overall application. Inline functions are automatically ignored their nature of inline if compiler decides that there is no cost optimization happening because of inline. That is not applicable to hash defined macros. I hope you have learned something new today about hash define and inline functions and how inline functions help us increase the application speed and also help us the encapsulation, that is object oriented methodology. Please do subscribe, comment and share if you like the video. If you don't like it, do let me know with your comments. I'll work on creating better knowledgeable videos. Thank you for watching.